Well, now it's time to complicate things a little bit. When you start the initialization of a class or interface, it gets flagged as undergoing initialization. Okay, then suppose we've got a class C that we're doing this to. Then what happens is we start the initialization of the superclass, which we call S in this case. That's if it hasn't been done already yet. And then during initialization of the superclass S, you could of course call a static method in C, the original class. Now that would of course require that C to be initialized. However, C of course is flagged as undergoing initialization, and any second attempt at initialization is not made. Okay, it's regarded as being okay, and the call to any static method in C will just go ahead. Now this avoids, of course, what would be a fairly obvious recursive sort of loop, where each class is trying to initialize the other class and never succeeding. But of course it can give access to fields in C before they've been initialized. And in this case, of course, they have the default value, which will be 0 for primitives and null for references. Now, of course, if you've got a final static field in it which has been initialized with a compile time constant, of course, then it will still appear to have the right value in it, because what the compiler effectively does is replace all occurrences of that with the actual value of the constant itself, because it's known at compile time. Okay, so let's see an example of that. Right, here's the slightly trickier example. What we got here is a class here, foo, where it starts here, and it calls baz.test. There's baz down there, and test is over there. Right, now that call is going to trigger initialization of baz. Okay, so it will do initialization, and what it does, of course, is flag it as undergoing initialization, and it initializes the superclass bar first. So here we are in here now, trying to initialize this first. So first of all, it will print out in bar init, as you can see there, and then it calls baz.test. What's calling baz.test is an attempt to call this here, and normally that would require baz to be initialized, but as it's undergoing initialization, it pretends it's already been initialized. So the call will just go straight ahead and call this, which will print out test done. Prints out test done I equals, and then the value of I, which of course has not been initialized yet, so it's 0. So that's why it prints out 0. And then it's going to return from that, and that's completed the initialization of bar. Now it will do the initialization of baz, which will trigger that. So the first thing that will come out is in baz init I equals, and its value, which is still 0. And then it sets I to equal m, which will set it to 1, 2, 3 at that point. And then it will return from that initialization, and finally call what it originally set out to do, which is baz.test. It will print out test done I equals, and then 1, 2, 3. Right, now what sort of variation can we get on this? Well, let's see. If that was static final and it was set equal to 1, 2, 3, then every occurrence of I would simply be replaced by 1, 2, 3. So this here would in fact be replaced by 1, 2, 3. And because the compiler can concatenate those two strings, that I there is turned into a string, of course, that entire string is replaced with in baz init I equals 1, 2, 3 as a string. So I is not even involved at all, and the same will be done there. So if that is a static final constant set equal to 1, 2, 3, that string is just replaced. Of course, not if you leave it unset and set it down there, of course, that's a different matter. Only if you explicitly type in equals 1, 2, 3 and have it marked as final.